Today we are going to discuss about a new area in pH calculation. First, I am giving you some equations for that calculations. That is number one. If we give a weak acid like CH3COH, that means acetic acid. For the calculation of pH, we have to use one equation, that is half into pKa minus log C. What is Ka? That is ionization constant of acid. What is C? That is initial concentration of acid. Here a new term comes. What it is? pKa. pKa equal to minus log K. We know pH is equal to minus log Kb. pH is equal to minus log H plus. Similarly, pKa equal to minus log K. If you give a weak base like NH4OH, ammonium hydroxide, here first we have to calculate pOH. How? pOH is equal to half into, instead of pKa, here pKb. Why pKb? Kb, that is ionization constant of weak base, and minus log C. See what it is? Its concentration. Then we are going through salt equations. If the salt of weak acid and strong base, an example CH3COONA, we have to use the equation pH equal to 7 plus half into pKa plus log C. Ka same, ionization constant of weak acid, but what is C here? That is concentration of salt given. Then number 4, salt of strong acid and weak base. Strong acid and weak base. Example NH4Cl, ammonium chloride. Still here we are calculating pH 7 minus half into pKb plus log C. What is Kb? Ionization constant of weak base. What is C? That is concentration of that salt. Okay. Okay. Now I am going to discuss about salt of weak acid and weak base. If both acid and base are weak, example CH3COONH4, ammonium acetate, we have the equation pH equal to 7 plus half into pK minus pKb. In this equation, there is no other term C, that is concentration of salt. That indicates if the salt is formed by weak acid and weak base, its pH independent on its concentration. Independent on its concentration for the salt of weak acid and weak base. And another one, salt of strong acid and strong base. If both acid and base are strong, example like that NaCl, you have no confusion, its pH equal to 7. That is, its pH is fixed, that is pH equal to 7. What is the meaning of pH 7? It is neutral. Which salt is neutral? It is salt of strong acid and strong base. Okay, now I am going to discuss about the two mixture. Mixture of weak acid, example CH3COH, and its salt with a strong base, CH3CONA. CH3COH is weak acid, its salt with a strong base, that is CH3CONA. In this case, pH is equal to pK. What is K? Ionization constant of weak acid plus log salt by acid. Salt means this one, its concentration, by acid, its concentration. Then mixture of weak base and its salt with a strong acid. Just to reverse, this pH, that is pOH. pKa, pKb plus log salt by acid, here base. So these mixtures are buffer solutions. Just I have given an additional point. These mixtures are buffer solutions. That is mixture of weak acid and salt with a strong base, mixture of weak base. Okay, now I am explaining my constant, that is find a pH of 2 molar CH3COH. CH3COH is weak acid having ionization constant. Ionization constant means it's Ka. What is 2 molar? That is its concentration C. So we have direct equation. What it is? pH equal to half into pKa minus log C. First we have to calculate pKa. How pK will calculate? that is minus log K, that is minus log 2 into 10 raised to minus 5. Then calculate log C, that is log of 2. By substituting these values in this equation, we can calculate pH of weak acid like CH3COOH. Okay, now I am explaining two questions. First one, find pH of mixture of 400 milliliter its volume, 2 molar its concentration, HCl. HCl means that is strong acid, and 400 milliliter 2 molar NaOH. We know HCl and NaOH are acid and base. They undergo neutralization to form salt. Here 400 milliliter of 2 molar HCl and 400 milliliter of 2 molar NaOH. That means number of moles of both acid and base are equal. So they undergo complete neutralization. And the salt will be NaCl. NaCl is the salt of strong acid and strong base. Its pH equal to 7. There is no need of calculation. Okay, if you give strong acid and strong base, and if it undergo complete neutralization, its pH should be 7. Why? It is salt of strong acid and strong base. Now I am giving another question. What it is? pH of mixture of 400 milliliter of 2 molar HCl and 200 milliliter of 2 molar NaOH. Here HCl and NaOH have 2 molar concentration, but HCl have 400 milliliter, NaOH have 200 milliliter. In this case, which is excess? That is, we can simply say that HCl. So after neutralization between HCl and NaOH, which will still exist? After neutralization of HCl and NaOH, which will exist? That should be HCl. That means H plus remains. So first we have to calculate concentration of H plus remaining. How it calculate? M1 V1 of H plus, I am giving an equation, minus M2 V2 of OH minus by V1 plus V2. M1 V1 of H plus, it indicates actually number of moles of H plus, minus M2 V2 of OH minus after neutralization by V1 plus V2. By using this equation, we can calculate the same problem. Okay. H plus remaining, how it will calculate? M1, that is 2 into V1 400 minus M2, that is also 2 into 200 divided by V1 plus V2, 400 plus 200. Here we will get concentration of H plus. After that, we can simply calculate pH. How? Minus log concentration of H plus. This technique is used during the mixing of strong acid and strong base only. We have to focus the point. This technique can be used during the mixing of strong acid and strong base only. Okay, now we are considering a new question. Find pH when 400 milliliter 2 molar CH3COH, that is weak acid, and 400 milliliter 2 molar NaOH mixer. When compared to question, we already discussed 400 ml, 400 ml, 2 molar, 2 molar. It undergo complete neutralization, so its pH will be equal to 7. It cannot be applicable. Why? CH3COH and NaOH are mixed together to get a salt, CH3COONA. A salt have its own pH and we have that equation. What is that? pH is equal to 7 plus half into pKa minus log C. What is C here? That is concentration of salt. C, concentration of salt, and Ka, ionization constant. In this question, you will give K 2 into 10 raised to minus 5. Ka is already given. We have to calculate first pKa. How? Minus log K. Here we have to calculate C. What is C? Concentration of salt. Concentration of salt. It is not given in the equation. C, concentration of salt is not given in the equation. How it can be calculated? Both the molarity of CH3COH and NaOH are same, that is 2. And volume 400. We have to divide by 800. Why? When these are mixed, their volume will be doubled. Volume will be doubled means concentration will be halved. So, that will be 1. Now we get C. So, log C have to be calculated. What is log C? Log 1. Now we get pKa. Now we get log C. So, we can calculate pH. Okay, let's discuss another question. 400 milliliter of 2 molar CH3COH and 200 ml of 2 molar NaOH are mixed. There will be salt formation, CH3COONA, and CH3COH have 400 ml, NaOH have 200 ml, which is excess, that is CH3COH. So, this CH3COOH still remain in the solution. That CH3COH still remain in the solution. It is the mixture of weak acid and its salt. Now it is buffer solution. Then we have pH is equal to pKa plus log concentration of salt by concentration of acid. Okay. What is pK? In this question also we should know K. That will be given in the equation 2 into 10 raised to minus 5. So we will calculate pKa, no problem. Then we require which one? Concentration of salt and concentration of acid. Okay. Concentration of salt. We can simply think that 400 ml, 200 ml. How many milliliter will react in this reaction? That is 200 ml. Both have 2 molar. So, that 2 into 200. Why? 2 molar, so concentration same. 400 and 200, which will undergo complete reaction, that is 200. It is taken. Concentration of acid remaining. What is concentration of acid remaining? It is 2 molar, 2 molar. From this 400, 200 react with the NaOH because NaOH is 200. What is remaining? That is 200. In this calculation, we don't want to divide by total volume because denominator and numerator have a concentration. So that division will be cancelled. Very simple. Concentration of salt is given, concentration of acid is given. We can substitute here. And by calculating pKa, that is pH will be calculated. These are the important questions in pH calculation. Thank you.